Chapter 4 Electrochemistry Part 2 Cell Potential. Electrons in different metals have different potential energy. The potential difference is termed cell potential. The maximum potential difference across a cell is its EMF, electromotive force. A cell potential, E cell, the sum of electrode potentials, E, of the two cells making up the electrochemical cell. The unit in volt. Electrode potential is a measure of the half cell to attract electrons. The more positive the half cell's electrode potential, the stronger is its attraction for electrons, such as Daniell cell. The electrode potential of copper is more positive than zinc, since the electrons flowing from zinc electrode to copper electrode. Electrical potential, cell potential, competition between two half cells. Every half cell has tendency to gain electrons and proceed as reduction half reaction. Reduction potential, E, relative ease of gaining electrons, standard reduction potential measured under standard conditions. Standard cell potential, E cell, when two half cells are connected. The one with larger, more positive SRP, meaning standard reduction potential, will acquire electrons and undergo reduction. The one with lower SRP will donate electrons and undergo oxidation. Determine the standard cell potential as the difference between SRP, standard reduction potential of one half cell, and SRP of other half cell. The more positive SRP represents the reduction half reaction, and we call it SRP reduction, and the less positive SRP will represent the oxidation half reaction and is SRP oxidation. The standard cell potential is E cell is equal to the E reduction for the reduced minus E reduction for oxidized. Calculating E cell. Look at reaction in zinc-copper cell. This is the zinc and this is the copper. This is the overall reaction. Zinc is oxidized. Copper is reduced. Half reduction reactions for zinc and this is for copper. Reaction for copper to iron must have greater tendency to proceed than zinc to iron, as copper to iron is the one reduced. E cell is equal to SRP, the standard reduction potential for copper to iron. So this is the reduced reduction minus with the SRP for oxidized. So zinc here is oxidized. Galvanic cell of copper and copper to iron with hydrogen electrode. This is at cathode for the copper and hydrogen at anode. So this is the net cell reaction or overall reaction. And here is the standard cell potential is equal to the SRP reduced minus with the SRP oxidized. Actually, don't confuse with this formula, because this is the SRP, meaning that the standard reduction potential measured under standard conditions. And this is actually for the reduce minus with the oxidize. RED is for the reduction. Okay, so this is the standard cell potential, and minus with the SRP, still with the reduction, and same goes here, reduction. But this is the reduce minus oxidize. And we know at cathode is reduction, and at anode is oxidation process. And this is the standard cell potential is equal to the SRP for copper to iron minus with the SRP for hydrogen ion. And you get for the SRP copper to iron is equal to the positive 0.34 volt. This is the example for the zinc and hydrogen electrode. And this is the same with the previous one for the copper, same formula. But for the SRP zinc to iron is equal to the negative 0.76 volt. For the standard reduction potentials, all tabulated as reduction potentials, oxidized form plus with the electrons will form the reduce. Can be ions, elements, or compounds, arranged from top to bottom by decreasing standard reduction potential or SRP. Positive values of SRP means substance is easily reduced. The positive reduce. The more positive value of SRP indicates reduction is more likely reaction. So meaning that is a more likely reaction for the reduction if the value of the SRP more positive. This is the example. Most easily reduce. And if the value of SRP less than 0, meaning that negative, means substance is easily oxidized. More negative value means oxidation. The substance is less likely to undergo reduction. So this is the negative value, but this is still the reduction, gain of the electron, SRP. This is the standard reduction potentials. And this is the negative value, so undergo oxidation process. And when reaction reverse, sign of SRP reverse. So look at this. If this one is the oxidation, first is the reduction, negative. If you reverse the product to the reactant, so the value of the SRP also, you reverse the sign. Using standard cell potential to calculate SRP of a half reaction. So this is the standard cell potential, positive 0.46 volt, and copper undergoes oxidation. So this is the SRP copper, positive 0.34 volt, and for the silver undergoes reduction. What is SRP for the half fraction of silver? So this is how you calculate to get the SRP for silver. Predicting if reaction is spontaneous, given any redox reaction, calculate the standard cell potential for reaction as written. If standard cell potential more than 0, meaning that the positive, then the reaction is spontaneous. If the standard cell potential less than 0 volt, this is the negative, then the reaction is non-spontaneous. Another view is that it is spontaneous in the reverse direction. Galvanic cell is always spontaneous because it is always set up so standard cell potential is positive. This is another example to identify whether the reaction is spontaneous or non-spontaneous. So you need to calculate the standard cell potential. And from the answer is the positive 2.24 volt, meaning that this is the positive volt, means a spontaneous reaction. Calculating cell potential. So this is how you predict the standard cell potential when magnesium and cadmium are added to a solution containing the magnesium 2 ion and cadmium 2 ions. So this is the equations for the reduction because gain electrons. So since cadmium 2 ion has the least negative value, so look at this cadmium, negative values, it is reduced and so magnesium is oxidized. And then use this formula for the standard cell potential is equal to the SRP for the reduced, meaning that the reduction, minus with the SRP for the oxidized, the oxidation, and equal to the, so this is the reduction is the cadmium, so meaning that it's the negative 0.40, you minus with the negative 2.37 volt of the magnesium 2 ion, and you get the answer is positive 1.97 volt. The spontaneous reaction is, this is the overall because this is the positive more than 0, the positive, so the cell potential is spontaneous. Try this tutorial